Hello guys, welcome back to your favorite channel Physique for NEET and JEE exams. I'm sure before watching this third part of mathematical tools of integration part, you have already watched the trigonometry and the derivatives. Even if you have not seen trigonometry, it's completely fine. But if you want to understand this integration video completely, it's my request that you please first go through the video of derivatives part, which you will find in the same playlist as this particular video you have found in the playlist of mathematical tools. Okay, so it's my request first watch the video of derivatives, and after watching this please watch this video. So guys, in this video we are going to do the final and the third and the final part, I should say, of mathematical tool, and we are going to deal with the very important, at the same time very difficult part of mathematical tools, and that is integration. Yes guys, integration. Now guys, I am going to take a reference of derivatives which we discussed in the last lecture. If you remember, in the derivatives what we used to do is, if we have a huge problem, we need to break it down into small parts, and when we break it into small parts, those small parts should be such small, so tiny, that we can assume that each and every part of this particular huge problem is identical. And that means I can apply a solution for that small part, and the same solution is applicable or will be applicable for all the parts, since all the parts are identical. And that is the advantage of derivatives. So guys, don't you think when you have that huge problem available, and in that huge problem you break it into tiny parts and you apply the solution to it, now when you want to apply that same solution for all the parts and find the sum of it to find the final big problem ka solution, which means the solution of the entire question, you have to add all the parts again, which you have broken up into small tiny parts. So don't you think to add them up, we have a very simple technique and something called as addition or summation. But guys, that thing is possible only if you have finite numbers, something like if I want to add 1, 2, 3, 4, 5 till say 100, 1000, 10,000. But what if I want to add numbers from 1 to infinity? That's completely impossible using the summation or addition idea, correct? At the same time, what if I want to add all the numbers from 1 to 2, where the intervals between 1 and 2 or between two consecutive numbers is like 0.000000000000000001. Now don't you think that means I'm trying to say I'm going to add like 1 plus 1.000000000000001 plus 1.0000000000002 plus 1.000000003. You're tired, guys. So just imagine if I go from 1 to 2 with such a small interval. Remember, I told you while taking the derivative that part should be so tiny that every part can be taken as identical. So I have to take such a small part, which means that small part will be so small that when you try to add them up, you will not be able to add them up using your normal summation or addition. And that's where our rescue team will come of integration. So integration is basically a tool, a mathematical tool, which helps you to add all those small parts without worrying about whatever or however small the limits are going to be, or however large the limits are going to be. So even if you go from 1 to infinity, or even if you go from 1 to 2 with an interval of 0.000000001, both the cases you can do that using integration. So guys, the basic idea of integration is the summation or the addition of all the small parts, and the number of small parts which you can add or which you can sum using integration have no limits. But yes, very important thing is you have a symbol of something like this, integration symbol, and you have say a function of x. I'm sure now you're familiar with f of x, that's a function of x, and you need to integrate it with respect to x. That is very, very, very important. Which means whatever function we have over here, you have to integrate it with respect to the same tiny small part of that particular variable. You cannot use any other part. Practically you can use, but those parts you can say it's not there in your syllabus. I'm talking about PCB students, guys. PCM students, you are anyways going to practice it in the MCQs of mathematics, numericals of mathematics. But here I am dealing with only the basics of derivative, integration and trigonometry, which is useful for physics. Okay. So you cannot have a different variable at this two position. You need to have the same variable. So even if you have different variables, there must be direct or indirect formula which you can substitute. It's like something, for example, if you have z as x cube, just an example, z as x cube, they might give you like this. And don't worry about it. It means you can substitute this x cube over here itself, and then you can get this as integration of x cube dx. Okay, so that means the variable which you are talking about the integration and the variable with respect to which you are going to apply the integration, it's going to be the same. Unlike the derivatives where you had, if you remember, du by dx, where u was the independent variable and x was the independent variable. Here the integration has to be between the two variables which are same. You don't have two variables involved over here. Even if you have, you will have some direct relation as per your physics syllabus goes. Okay? So I hope this part is clear to you. Now integration basically are of two types. In derivatives you didn't have any type. In derivatives, let's say if I want to calculate some value, I would just say find the derivative of so and so function at a given value of this. Say for example, if you have some function, when you get the answer in the form of some equation, let's say in some form of x, I will give you the value of x to find the value. So it's simple, it's just one type. But integration are basically of two types. Yes, one is definite and other is indefinite. So they are quite the opposite, right? Yes, guys, definite means I am giving you the limits, the lower limits and the upper limits. The example which I gave you, 1 to infinity or 1 to 2 with a small interval, that's definite. So I'm giving you the boundary between which I want to find the sum of all the small parts. And when I don't have that limits available for me, at that point of time, I say I go for indefinite integration. So when I go for definite integration, the method at the end, the formula remains the same, but the method at the end for both of them is bit of a different. And we are going to discuss both of them. Don't worry about that. Okay, so please copy this so that we can go ahead. So guys, I hope you have already copied the entire concept of it, and I'm sure you understood that there are two types, definite and indefinite integration. But before we go for that types of integration and how to apply it, let's first try and understand how do we deal with integration in the graph section. Okay, so let's try and understand that part first. So what if we have acceleration versus time graph, let's say something like this, okay, and I want to find something called as velocity. Now guys, this is very important and very interesting. Okay, pay attention to this. Here I have 2 points marked as say T1 and T2. Definitely there is an acceleration over here A1 and A2. Now here my aim is to find the velocity. So guys, the velocity over here can be represented using something called as area under the curve. Yes guys, area under the curve, this area. Now don't you think if you want to actually find the area under the curve, I can break this entire area, this is from T1 to T2 and A1 to A2, into small tiny parts. Correct? Small tiny parts. Now each part is so small that it appears almost as a rectangle. Correct? That appears almost as a rectangle. Now when I say it appears almost as a rectangle, I'm sure you understand the area of the rectangle is length into breadth. Here the length is that small time interval and the breadth is going to be that acceleration, and that acceleration is constantly changing. So can I say, if I have the idea of how the acceleration is changing with time in the form of some equation, so my acceleration is going to be some function of time. Correct? So I can do the integration for every small tiny time interval dt from t1 to t2 as the two limits. Hai simple. That means I can say the velocity is going to be integration of acceleration with the time interval of dt. And that means I can write instead of acceleration as f of t. So guys, basic idea, if you understand that if I have the velocity and if I take the derivative of that velocity with respect to time, I get the acceleration. So similarly, if I want to find the velocity, I need to multiply this time interval over here and to find every small change in velocity and add it all up to find the velocity, which is integration of dv and so integration of adt. Guys, so I hope you understood that for derivatives, I'm actually breaking the entire graph into small part with the time interval or with the x interval for a given y interval. For the integration, I'm doing the exactly opposite part. I'm taking the two limits, or even if I don't have the limit, I just take whatever part I have and then I apply the area under the curve. In using that area under the curve, I'm actually multiplying and then adding all those parts, all those intervals to find the total area. Now to practically use this, we can have this something like this. Let's say I have a graph of acceleration versus time like this. I can say the acceleration is constant. Am I correct? So acceleration is a, let's call it as a, which is a constant. In that scenario, can I say, if I take area under this curve, the acceleration is a over here and time is say some t. I don't know the limit, okay? I don't know the practical value, but I just know it's some time t. So can I say the area under the curve is going to be length into breadth, that is a into t, which means velocity is going to be a into t. And that's actually not going to be the a velocity, but actually it's going to be, yes, change in velocity. Like I got the change in velocity from a into dt. Correct? Similarly, I can do the integration over here also. Have a look. I can say f of t, or acceleration, is a constant. So integration of a dt. Yes, I'm not taught you the formula, so I'm just going to apply the formula and you have to remember that I'm going to teach you the formula, don't worry about it. Okay? So I can take the constant outside. Like if you remember in derivative also we take the constant outside. So acceleration, constant into integration dt. Yes, and integration dt is practically in formula we are going to learn is equal to t. So we are going to get it as at itself. So whether you go for area under the curve or whether you go for integration is the same thing. So in graphical section I can say the slope between 2 points, or actually slope at a given point, is derivative, and for a graph finding area under the curve either between 2 points or in general condition is nothing but the integration. So integration in graphical section means area under the curve. Okay guys, so please copy this. In the next part, we are definitely going to understand over here about the formulas also. So this particular part will get clear. Okay, so don't worry about it. Please copy. So guys, I'm very much sure that you have copied the entire part, and I'm very much sure that you have understood a very basic thing about the derivation and integration, and that is that derivation and integration are exactly opposite. Where in the derivative you actually break the huge problem into small tiny parts, in such a small tiny part that every part is identical, and so you apply the solution to one small part, and then you're going to add all the small tiny parts to get the solution of the huge problem, and that is nothing but the integration. So breaking into tiny parts is derivative, and summing up or adding up all the tiny parts back into the original thing is going to be our integration. Okay, so derivative and integration is quite the opposite of each other. So the properties also is quite similar. The formulas are also quite the other way around of each other. So let's go ahead with the properties. The first thing is derivative of the dx, which means you don't have anything apart from the dx, which means it's basically 1, you can call it as. Okay, so integration 1 dx goes with as x. So the formula for integration of dx is x. But if you go for integration of f of x plus f or f1 of x and f2 of x with dx. So if you remember, in derivative, when you have addition or subtraction, you used to apply the derivative in both the parts and separate them with the help of a plus or minus sign. Same thing over here. Here we are going to separate the integration sign as f1x dx integration plus f2x dx integration. So similarly, if you have the minus sign, f1x minus f2x, the whole dx, it will be going to be integration f1x dx minus integration f2x dx. So whether it's plus or minus, you just separate the integration and you apply it. It's quite simple, correct? Then you have, what if there is a constant with f of x dx? Okay, so if there is a constant involved, you take the constant outside and then you apply integration for f of x dx. The constant is not going to hamper your calculation. Same way in derivative also. But now comes the important part for indefinite integration. Now what is the difference between indefinite and definite? We are going to deal with that. For indefinite integration, we do not have any limits, right? So in that scenario, whenever you go for integration of say f of x dx and you get the output in terms of some another function of f of x, say, okay, you have to write plus c. That c is called constant of integration. Because I hope you understand, if you remember, if I say that the integration of this is this, the derivative of this is going to be back this, correct? Because they are just the opposite of each other in terms of derivative and integration. So when you do the derivative of this, the derivative of f of x, capital F of x, is going to be small f of x, no problem. But the derivative of constant is going to be 0. Now that means while doing the integration, we do not know that is there any going constant present or not. So better to write that as a c, constant of integration, and using the condition given in the question, we can find the value of c if needed. Or otherwise we just leave it as plus c, not a problem. But whenever you use indefinite integration, which means no values have been mentioned as a limit, upper and lower limits if you say, then you have to write with the formula or with the answer plus c. So practically I can say everywhere I have not put any limits, right? So everywhere after writing this answer x, I should write plus c. Or after getting the values of this, I should write plus c at that. I may not write c1 and c2 as two constants. I don't need that. I can write a plus c1's constant itself because c1 plus c2 can represent a c. Correct? So I don't need to write multiple constant, but yes, after applying indefinite integration, where there is no limits given, you have to write plus c, which is called as constant of integration. Okay. The second, that is definite integration. That's going to be like integration f of x dx with the limit as a to b, which means the lower limit of x is a and the upper limit of x is b. That is how they want you to integrate it. So now definitely small f of x ka integration, you get it as capital F of x, correct? So that is going to be the answer, no doubt about that. But with that, this time you're not going to put plus c. Instead, in the bracket outside you're going to put the limits, the lower limit a and the upper limit b. So now when you try to find the final answer, you have to substitute the value of this x as b. What will be the value? That is going to be the upper limit. Then f of x, where x is a, that will be the lower limit. Now if you want to find the interval, definitely you have to go for upper limit minus lower limit. So we get f of a minus f of b as our final answer. So guys, here if you understand, you do not have that multiplication and division wale sums or division wale formulas or properties. The only reason is I am still talking about the mathematics required for physics, and I'm strictly talking about PCB students, which they need to learn mathematical part for the physics. So PCM students, please don't try and misunderstand this or misunderstood this video, because this video is not as you can say specifically for PCB students only, it's for you also. But I would just recommend that these are the particular formulas, these are the particular points which are more often used even in NEET as well as in JEE mains. I repeat, JEE mains, not in advance. Okay, so definitely in JEE mains you may have certain formula extra apart from this. Right now I'm not taking care of that. That you can ask me in the comment section. I will definitely add those formulas also and make the separate video for it wherever it is used in some or the other MCQs, and I will definitely provide you the solutions for those. But yes, right now my concentration is only those kind of formulas and those kind of data in mathematical tool which will help all the PCB and PCM students in general at the same level. Okay, so guys, these are the properties which you need to copy, so that after this I can give you the list of formulas and then we can go ahead with the examples. I hope you have understood the definite and indefinite also. In the example, I'm going to solve that kind also so that you will understand better. Okay, please copy. So guys, now I'm sure that you have applied or you have copied all the properties. Now we go ahead with the formulas. Like in derivative, we have done a lot of formulas. In integration, you don't have that many formulas to worry about. But I can definitely say whatever formula we have done in derivatives, the other way around is going to be the integration. So if you want me to give an example, I can say derivative of x raised to n was n x raised to n minus 1. Am I correct? Then I can say integration of n raised to n then x raised to n minus 1 dx. That means this is taken over here and this derivative is converted over here to integration, and that is going to be x raised to n. Definitely, if you go for the indefinite, there is going to be plus c. If you go for definite, then there will be some limits, upper and lower limit, and then you are going to substitute it. No doubt about that. So whatever formula we have done in derivatives, those all formulas you can apply for integration in the reverse order. But apart from that, we have some general formulas which you will be able to use or you will be using it in certain numericals and MCQs. So I'm giving you those. Okay. So the first one, integration of x raised to n dx. Yes, derivative we know, the same thing which we want to integrate. Then it is x raised to n plus 1 upon n plus 1. So if you actually compare, while doing the derivative, the power decreased by 1 and we multiply by the power. Here, the power increased by 1 and we divide by that addition of that power. So now if you try to actually apply this over here, I can prove this using this formula. See, this is a constant, so goes out. We have integration of x raised to n minus 1 dx. Now, definitely I hope you understand here n is n minus 1. So if you add 1 to it, it becomes x raised to n. And definitely we have n over here upon whatever power is in the given above x, that's the same thing which we divide with. So n. And so this n and this n gets cancelled. And we got x raised to n, which is, I wrote over here. So I hope you understand that derivative formulas is same as the reciprocal or the reverse, I should say, of integration. Okay. So the next formula I'm going with is integration of 1 by x dx. I'm sure you can make it up now. Yes, we have done this in derivative the reverse way. That is natural log of x, because the derivative of log of x was 1 by x. Yes, the third one, integration of e raised to x dx is going to be the same, e raised to x, because the derivative also remains the same. Yes, the fourth one, integration of e raised to ax, if we have. Yes, over there we multiplied, in derivative we multiplied with the constant. Here we are going to divide with that constant. So that means we are going to have e raised to x, ax, upon a. So that's the difference. Okay? Yes, then the fifth formula goes as integration of sin x dx. Yes, I hope you remember the derivative of sin x was cos x and derivative of cos x was minus sin x, which means the integration of sin x is going to be minus cos x. Correct? And then we have the last formula, integration of cos x dx as sin x. So guys, in integration, you don't have to worry about much of a formulas, but yes, yaad to rakhna hi padega. You have to remember all of them. Yes, so please copy all these formulas. These are very important. And now after this, we are going to go for some numericals for practice. And as an extra prize to keep attending all this half an hour, 40 minutes lecture, I'm going to do one derivation, one special derivation, which will help you to understand how exactly the derivatives and integration helps in the real mathematical world. Okay, so please connect with it and please copy this. So guys, I'm sure formulas you have done copying and everything. So these are the three examples which we are going to solve like we did in derivatives. Yes, we have integrations, two with the indefinite ones, and one, as you can see, with the definite ones, we have the limits. Okay, so we are going to solve this, but again, I would request you to pause the video over here, try and solve this sum by yourself, and then come back and see the solutions. Okay, so here I'm assuming that you have paused the video, got the solution by yourself already. Let's go for it, how we solve it. Okay, so let's go for the first one. First one is integration of x raised to 8 dx. Now if you remember, the integration of x raised to n dx, the formula was x raised to n plus 1 upon n plus 1. Correct? That is the general formula. So we are going to apply the same. Here the n is 1, n is 8. So it's going to be 8 plus 1 upon 8 plus 1 over here. So that's x raised to 9 upon 9. Now we cannot just write this as it is. We have to write plus c, the constant of integration, because the limits have not been given, which means this is an indefinite integration. So that plus c represents the constant of integration. So I'm sure you got this as the answer. That's it. This is the answer. Okay. Now let's go for the second one. We have x squared dx with limits 2 to 5. Again, we are going to apply the same formula here. So we're going to have x raised to 2 plus 1, that's 3, upon 2 plus 1, that's 3, with limits this time 2 to 5. Okay, lower limit is 2, upper limit is 5. Now when I say substitute the limits, this is what I meant. You have to substitute x ki jagah pe, in place of x you have to substitute 5. So this is going to be 5 cube by 3 minus now the lower limit as 2 cube by 3. Okay, so now 5 cube, as we know, is 5 into 5 into 5, so 125. and 2 ka cube is 2 into 2 into 2, that's 8. So basically we have 125 minus 8 by 3. Correct? So now if we subtract this, we get around 117. Yes. So we have 117 by 3. Now is it divisible? Divisible? Yes, yes, it's divisible. We have 3 ones are 3 threes are 9. We are left with 2, 27, 3 nines are 27. So 39 is your final answer. And here you don't have to write that plus C, because definitely we have already put the limits and we have got a finite value. Okay. So now we go for the last sum, third sum. Yes guys, here as we can say it's the addition of two functions. So we separate them as per the integration. So we get integration x dx plus integration sin x dx. Now guys, many of you make a mistake over here as x dx. Now how to solve this? There is no formula taught for this. Guys, you need to understand x dx means x raised to 1 dx. So here the value of n is 1. So we are going to use this formula only with n as 1. That means x raised to 2 by 2. Correct? 1 plus 1 is 2. Plus, I'm sure you remember integration of sin x is minus cos x. So minus cos x. And so our final answer is x square by 2 minus cos x, and yes, plus c, a constant of integration. So guys, you need to understand this. I'm sure it was quite simple for you now. So please copy this so we can continue. Hello guys, so I'm sure you have copied the solution, and as I promised, since you have watched the video till the very end, I have a small surprise, an extra part for you, which will help you to understand that how exactly this derivative and integration is helping us in the mathematical part. I'm sure guys you know that if I go for a circle, the circumference of the circle is 2 pi r. Yes guys, I hope you know this. And yes, I'm sure you know the area for the circle is pi r square. But guys, anyone have any idea how this formula has been made? No, right? Many of you might not be knowing this, how this formula actually came up. So in today's part, in the last part, I'm going to teach you how exactly this formula has been derived. And I will teach you the method of it, how to use integration and derivative for it, how to break this problem into small parts, and how to integrate and how to get the entire solution for it, so that you can also do the same thing for the sphere, the three-dimensional world. Okay, so this we are doing with the 2 dimension. Let's do that first. Okay, so let's go ahead. Can I say the circle have a basic property that every element of that circle, every particle, every point on that circle is at equidistant, let's call it as r, from the point O, let's call this point O, the center of the circle. Am I correct? Which means if I just join the point O with any point on the circle, let's call this is point P, the distance is going to be r. Am I correct? Now let's imagine there is a guy who is standing at point P tied with a rope which is fixed at point O. Now that guy wants to walk. Don't you think when it is walking, it's going to walk round and round, round and round, which means it is going to round the circle, correct? And that means, guys, if I give him a very small time interval such that it goes from point P to point Q, and while doing that, he have covered a very small displacement, say delta S. Instead of delta S, let's call that as ds. A very, very tiny, tiny, tiny. So can I say in that scenario, the angle which is made between that point PO and line QO, yes, that angle is also going to be very, very small. I guess the symbol which we use for the angle is theta, right? So can I call this angle as d theta? Now guys, something very important coming up. I'm sure you have done something called as measurement. In the measurement, you have done something called as supplementary physical quantity. In that supplementary physical quantity, I'm sure you must have learned something called as plane angle. I hope yaad hai. Yaad hai, yaad hai, yaad hai, yaad hai. Everyone yaad hai? Yes. Then can I say d theta is actually equal to ds by r? Now those of you don't know this. Those of you don't know this. Yes, or might not know this. Why not do this also? Okay. Let's make this a triangle. Can I say the side is so small, so small, so small with respect to the circle? It's almost like a straight line. Can I do that? Yes, I can do that. If you want an example, the place where you are standing, where I am standing, don't you think it's earth which is curved? But do you go on that side and feel that you are tilted over here? You go on that side, you feel tilted over here? No. Why? Because the space what you are occupying compared to the size of the earth is so small that the curvature is almost a flat region. Same way, with respect to the circle ka size, I'm saying this size is so small that it appears like a straight line. In that scenario, can I say this appears almost like a 90 degree? Both cannot be 90. If both are 90, then these two lines are parallel, never going to meet. That's not possible. So both are not 90, one is 90. And both the sides are r, almost r. And this is ds. This angle is d theta. Now, do you remember something as sine of angle is O? Remember the first lecture, guys, trigonometry. O, opposite upon hypotenuse. That is ds by r. Now, tan of some angle. I hope you remember, guys. OA. Yes, opposite upon adjacent. That is ds upon r. Can I say sine theta and tan theta both are same? Now that is possible, guys. Both the angles will be same. Both the sine and tan is possible only when this is also equal to d theta. That is the angle itself, provided it is in radian. Now, if you want me to prove this also, very simple. Get your calci, put sine of 1 degree and get the value. Then put tan of 1 degree and get the value. And then convert 1 degree into radian. I hope you know how to convert 1 degree into pi by 180. Simple. Pi ka value 3.142. Substitute, divide by 180, get the value. I guarantee, guys, you get all the things to be same. So for small angles, it is true. So if sine theta, d theta, tan d theta, d theta, all three are same, can I substitute over here d theta only? And that means this is this. I hope you got it. I hope you got it. I hope you got it. Everyone, I hope you got it. Correct? So now can I write ds as r times d theta? Now, ds is a small length of arc. I want the circumference. Can I say circumference is the addition of all the small arcs such that it starts from the point and ends on the same point? Correct or not? Which means I have to do integration, guys. Yes, I have to do integration. Which means the circumference is going to be integration ds, which means integration r d theta. Correct. Now I have to set the limit. Yes, I have to set the limit. Don't you think starting angle is 0? And when you complete the entire circle, it is a 360 degree. Yes, very good. So 0 to 360. But there is a problem. You cannot put 360 degree because your theta is in radian. So guys, 360 degree is how many radian? 2 pi radian. So I have to put 0 to 2 pi. I hope you got the limit. You understood the limit? Yes, everyone, sure. So now I can say r is a constant because it's not going to change at any point. So r comes outside. Integration d theta from 0 to 2 pi. I hope you remember integration dx was x. So here r integration d theta is theta from 0 to 2 pi. Let's substitute. R into upper limit 2 pi minus lower limit 0. 2 pi minus 0 will be 2 pi, yes, and we get the answer 2 pi r. So guys, circumference 2 pi r, which you have rectified in your school standards. This is how exactly it has been derived. So next step, definitely we are going to derive the area also. But for that I need some space in my board. Please copy this so that I can rub it and we can go for the area. So guys, I hope you are excited now to go for the second proof, and that is the area proof. And I'm sure you have copied the first proof of the circumference. But yes, because the first proof is very important, because the second proof requires the first proof, the formula, and that is 2 pi r. Okay, so we need that. Now, can I say again a circle? The radius is r. Now I want to find the area. Don't you think the area is actually this. As you increase the radius of the circle from 0 to r by small values dr, the addition of all the circumference from 0 to r is going to give you area. Yes, so addition of all the circles is going to give you the area, which means what I've done is I've break the entire circle into small circles, and the circles interval, the interval between them, the radius is going to be dr, very chota dr, very small dr, right? Which means if I draw this, I can say, let's consider a circle of radius x having thickness dx. So it's a circle having radius x and having thickness dx. So my circle is increasing by every dx. Wow. So now, can I say, if I want to find the area of this part, I want to find the area of this part. Can I say it's going to be dA? Because it's a small circle, so small area, dA. Can I say it is going to be the circumference of this circle into the thickness? So 2 pi x, as per the formula, circumference into the thickness, dx. So our area is the circumference into the thickness. We want the area. Guys, we want the area. Integrate it. Simple. So area is going to be integration of area dA, which is integration of 2 pi x dx, where x, the minimum x will be 0 and the maximum x will be r. Am I right? So 0 to r. Because I have to integrate, I have to sum all the circumference with the thickness. Am I right? That means 2 pi is a constant, goes out. X dx is like x raised to n dx, where n is 1, which means x raised to 2 upon 2 with limits 0 to r. Yes, 2 pi into upper limit r square minus 0 upon 2. Definitely this 2 gets cancelled. And so our area comes as pi r square. That's the proof, guys. That's the proof. You have been rectifying the whole life. Circumference as 2 pi r, area is pi r square. Circumference as 2 pi r, area is pi r square. Now you know how it came. So congratulations, guys. You have understood the derivatives and integration. And I'm sure you have rectified the trigonometry formula, because that formulas have to be rectified whether you like it or not. Correct? So here we come to an end of our mathematical tools, and I'm definitely sure this all the 3 videos of trigonometry, derivative and integration have helped you a lot, and that guys definitely deserve a hit like button दबाओ, जल्दी से दबाओ, and subscribe to our channel यार. इतना मेहनत कर रहा हूँ. I'm working so hard for you. So I deserve for you to get my subscribe, right? So subscribe our channel, like the video, and even share it if you want, guys. You can share it. I don't mind. I would love that. I would appreciate that. And also comment whether you like it, you don't like it, you don't understand it, you understand it, you want something, you don't want something, whatever you want to tell man on the comment section. I will reply, man. Okay, guys, please copy this, and that's it for the day. I'm sure you have understood all the parts, and sayonara. Bye bye, everyone. Take care. Okay, chalo, bye bye.